Hello everyone, welcome to the platform of Unacademy, India's largest online learning platform where we are studying the chapter of casting, which is a subject of manufacturing. So I welcome you all to this amazing platform of Unacademy, and we have already seen the four parts of the casting. This is going to be the fifth part. So I welcome you all. So this is a brief introduction about myself. My name is Vidyapati Kumar and I have a 4+ year of teaching as well as research and development experience. I have done ME from Jadavpur University and my specialization was production. I have worked at CSIR, Central Institute of Mining and Fuel Research. I have qualified GATE twice and I'm the author and co-author of various research papers of national and international journal of repute. If you have a keen interest, feel free to Google about my papers and study about them. You can follow me at unacademy.com at the rate of v.k sir. I post a lot of videos for strength of materials. I have completed the two modules there. So if you have an interest, then you can follow me so that whenever I will post a new video or schedule any other subjects, you will be notified for that same. Now, this is going to be the fifth part of casting, and we have seen a lot of things in this fourth part of the casting. And in this casting fifth part, we are going to see some of the rules, some of the things, total solidification times, what about the pressurized gating system, non-pressurized gating system, and we are going to solve a lot of previous year questions so that we will be more confident after this class to with the problems of the casting. Okay, you can download the Unacademy Learning app because in Unacademy Learning app there is a benefit of that. Here in Unacademy Learning app there is a free classes, there is a free classes and there is a paid classes. So there is a plus subscription you have to take, and in the plus subscription 100% coverage of the subjects are there. 100% coverage of the subjects are there. But let me tell you about the free classes. There is a special classes, there is a special classes in this free classes section where I am taking strength of material, where I have already completed the first module of stress and strain and the second module of the principal stress and principal strain. Currently I am teaching their strength of material of module 3 of shear force and bending moment diagram. So I am taking the classes at 9 a.m. So whosoever wants to join the free classes, they are most welcome to join my free classes. So the benefits of the app is daily live classes are there, structured courses are there, live tests and quizzes are there, and unlimited access of the contents are there. Okay. So these are some of the good benefits of the Unacademy Learning app. Apart from that, if you want for a plus subscription, if you think about you are planning for a plus subscription, then you should do that because there is 100% coverage of all the syllabus would be there, as well as apart from the 100% there is that each an educator will give you the doubt clearing sessions would be there, doubt clearing sessions would be there, as well as EYQ sessions would be there, a lot of sessions would be there, so that whosoever has enrolled in this plus subscription, they should get a benefit and they should crack the gate with not a good marks, they should be a ranker. So apart from that, there is a mock test, live test, quizzes are there. So multiple things are there at that platform, as well as structured courses are there. So these things are there, and if these are the top educators at the platform of Unacademy, and for a GATE and ESE, Unacademy has a lot of batches as well as for the different branches. The content materials are there, be it mechanical, civil, electrical, electronics, instrumentation, production, IT, everything. So now if you're planning for a plus subscription, there are the for a 1 month it will cost around 5,000, for 3 months it will be cost around 12,500, for 6 months it would cost around 20,000, and for a 12 months it would cost around 25,000. But if you will use my code SIRVK, then you will get a 10% off, and the discounted amount would be 22,500. Similarly, if you're planning, if you're in second or third or a fourth year, you should go for a 24 months plan, and it will cost around 30,000. It will cost around 30,000. But if you use my code SIRVK, SIRVK, then you will be getting a discount of 10%, and the discounted amount would be 27,000. So if you will see the per day calculation, approximately you are investing 60 rupees per day for a 12 months plan, and 37 rupees per day. So these per day calculations, like investing these money for a day, I don't think these things are very much. But if you can afford, go for it, because it is worth it. And if you can't, then stick with me. We are going to learn a lot of things, right? So go for it, go for a plus subscription. And so this is what is there. So before starting, let me check the comment box. It's a request for from me that please maintain a decorum. Okay, it's a request. It's a very kind, humble request from me to maintain a decorum, because here we are. It's like associated to learn manufacturing, right? है ना? एक decorum maintain करके रखें. You all are engineering students, right? And if you will maintain a decorum, then only educator also feels good, right? Okay, it's a very humble request. I'm sure what I am telling, those persons would able to understand what I am telling. Okay. Suresh ji, I have already completed the topic of metal cutting in the lead gate channel. You can always search about in the YouTube Vidyapati Kumar metal cutting. You will get a lot of videos. So 13 14 videos are there. You can go and study with that. So I have already completed metal cutting, and I am completing the casting part. So I will try my best to complete each and every topics of manufacturing, so that you will be benefited for the GATE and ESE examinations. Good evening, Ashish. Good evening, Mukta. Good evening, Indrajit. Good evening, Shivam. Arun ji, namaste. Vikas ji, good evening, good evening, good evening to everyone. Good evening. So let's start our beautiful session, right? Beautiful session. Let us say this is a very beautiful session. Okay. So let us see what we have been studied till now. हमने इससे पहले क्या पढ़ा था सर? तो लेट अस रिवाइज लिटिल बिट, बिकॉज कल जो मैंने जो चीज पढ़ाया था वो बहुत इंपॉर्टेंट है सर. ठीक है, सभी को गुड इवनिंग. जल्दी जल्दी ज्वाइन कर लें, सभी को गुड इवनिंग. जल्दी जल्दी ज्वाइन कर लें, और हम लोग अपना पढ़ाई को स्टार्ट जल्दी करते हैं. ठीक है, कल जो हमने पढ़ा था वो बहुत इंपॉर्टेंट है सर. एंड लेट मी अगेन टेल यू व्हाट आर द थिंग्स. चलिए एक बार क्विक रिवीजन करते हैं सर. सो दिस इज द पोरिंग बेसिन, राइट? This is the pouring basin. In this pouring basin, we are pouring the molten metal. Clear? We are pouring the molten metal. And what about that? After pouring the molten metal, see, these are the heavy impurities that actually lie on the bottom of the pouring cup. Clear? And see, there is a metal plate. Here we put a metal plate which actually reduces the velocities whatever there. So if the velocity will be reduced, hence there would be a laminar flow, because if there would be a turbulent flow, then there would be a chances of of the sand erosion, clear, of the sand erosion. And we do not want the sand erosion, because see, here we have a mold cavity. If the velocities will be very abrupt in different sections, that is turbulent in nature, then my mold cavity will collapse, right? When then my mold cavity will collapse, it will be ruined. So this is a necessity that it should be laminar in nature, clear. To make it laminar, we use a metal plate. After that, what we have seen, since these molten metal contains the impurities, so we put a strainer, right? We put a strainer. This is a strainer, and this strainer is made up of porous ceramic material, clear. This strainer is made up of porous ceramic material, and here the impurities are actually restricted है ना. इसको कैसे समझ सकते हैं सर? फॉर एग्जाम्पल यू कैन थिंक अबाउट चाय छन्नी, है ना. जब हम चाय बनाते हैं, तो चाय को पोर करते हैं किसमें? चाय छन्नी में पोर करते हैं, है ना. तो क्या होता है वहां पर? सम जालीदार पार्ट्स होता है, जहां से नीचे हमारा चाय निकल जाता है और ऊपर चाय पत्ती रह जाता है. So this is the same way. What we can assume in this situation is that here is a strainer, and this on this strainer, the molten metal is going down. Clear? The molten metal is going down, and see, the bigger size impurities, the size of the impurities, if the size of the impurity is much more, then they will stick here. But after that, it will go down. Now see what happens. 95% of the impurities are getting separated at the strainer stage itself, okay. But what happens, there are some of the 5% of the smaller size impurities that also comes with it. So at this point, there is a skim bob, there is a use of a skim bob. And skim bob, what skim bob does, that whatever the impurities, it will take it in the upper part and in the lower part, and hence it try to subside the impurities. And once the impurities will get subsides, it will get reduced. Then the pure molten metal is poured into the molten cavity, and then we are getting a very nice and good casting, okay. So this is what is the thing that we have seen. Good evening, Ravi ji. Vikas ji, today's topic I will let you know, just कर ही रहे हैं. Good evening, Subham ji. Subham, I will make a separate video for a quick revision for that, okay. पहले just complete कर देते हैं. And recently I'm also planning a quick revision for metal cutting, okay. I'm also planning for a quick revision, to make a quick revision video for metal cutting. And once I will finish the casting, I will do the same for it, okay. Because I can understand quick revision is very much important. Good evening, Rohit. Good evening. चलिए. गुड इवनिंग रोहित जी. गुड इवनिंग. चलिए अब देखते हैं. सो दिस इज व्हाट वी हैव सीन टिल नाउ. दिस इज व्हाट वी हैव सीन इन द yesterday's lecture, clear. So yesterday lectures we have seen these things. Now one more thing that we have seen is this, the AS. What is the AS? AS is the area, bottom sprue area, runner area. So this is the runner area is AR, and the inget area is AG, okay. Now, what we have seen apart from that is the top gate, right? So, types of gates we have seen. That what are the types of gate? Like top gate is there, bottom gate is there, parting line gate is there, and step gate is there. We have also gone into some much deeper details into that, and we have found that the top gate is like what? There is a riser, there is a runner, and the gate. So if gate is on the top of a casting, gate is on the top of a casting, hence we can say top gate, clear. Hence we can say top gate. if I have a riser arrangement and this gate is there and this gate is there, gate is at the bottom of the mold cavity. Clear? So suppose this is my mold cavity. In this mold cavity, what is there? I am pouring the molten metal, right? So this is my mold cavity, and from here I am pouring the molten metal. So molten metal will come and acquire this mold cavity, and hence the casting will be formed. So see, this molten cavity is entering from the bottom part of this casting, and hence it is known as bottom gate. So if gate is at the bottom part of the mold cavity, hence it is known as bottom gate. Now what is the parting line gate? See here once again, because in yesterday's class you all have a problem with the parting line gate. See, if this is a riser, if this is a runner, and the mold cavity is in such a way, mold cavity is in such a way that the axis, if we draw the axis, that is if we draw the parting line, so we can easily visualize that there is a mold cavity is separated in the two sections, right? Mold cavity is separated in the two sections. Let us consider this to be a one section, section 1, and let us consider this to be a section 2. Clear? So now if you can visualize this like this, so if this is my section 1 and this is my section 2 and this is the riser, so this is the one riser and the gate, right? So one gate is coming to at the bottom part, so we can see at the bottom part when it was there, so we can assume this condition to be a bottom gate condition. So assume this condition to be a bottom gate, and see this is this gate is at the top of the mold cavity, so we can assume this condition as a top gate. And what we can do, we can assume the condition of a bottom gate, and we can apply the formula of pouring time of the bottom gate, we can apply the formula of pouring time of top gate, and hence when we will find the pouring time of both the things, then I will add them, and then I will get the net pouring time in this parting line gate, right? We have seen these things. And next thing is the step gate. So what is the step gate? Just let me rush to this step gate concept. See, what is the step gate? What is the step gate? So there is a riser, and to fill the molten metal, right, whatever the molten metal is coming, so step gate is actually desired in case of a very humongous and big size mold cavity is there, right? Suppose if I want to make a road roller, right? A road roller देखे है ना, उसका बिग कितना बड़ा बड़ा होता है, उसका जो व्हील्स होता है, ठीक है, वो बहुत बड़ा होता है. फॉर एग्जांपल इफ आई एम इंटरेस्टेड टू मेक a lead bed of very big size, right? So like you can think about that these casting are not very small, right? For example, if I am doing a casting of this mouse and I am doing a casting of a road roller or a leather bed, right, or a milling bed, whatever is there, so there is a difference between them, there is a difference between them. For this I do not have to think about it, I can do anything, but for them I have to plan something. And like these are like very big in size, so a lot of molten metal is required to fill them, as well as there is a lot of things are there. So what we do to fill the molten metal very fast, here we give some steps, right? We give some steps. So what is this step? In the form of steps, these are provided, and the molten metal is poured from here, molten metal is poured from here. This is the case of a step gate, and this is the case of a step gate. And after that we have seen the top gate. We have derived the formula pouring time for a top gate, and we have found the pouring time for a top gate is the vm means mold volume, right? So volume of the mold cavity. So volume of the mold cavity by AC choke area into Vmax. What is the concept of choke area? What is the concept of choke area? Okay. Okay, so I haven't written here. Okay, see here. What is the concept of a choke area? Because the concept of choke area is very much important. Just now we have seen there is a sprue area, there is a runner area, and there is a gate area. Clear? Now I am defining the sprue area with AS, defining the runner area with AR, and gate area with AG. So these are the nomenclature. So AC, that is the, let us consider the choke area to be the minimum of a sprue area, a runner area, or a gate area. So whichever the area is going to be the minimum, I'm considering that area to be the choke area. Clear? For example, for instance, that I have considered my sprue area. My sprue area is 500 millimeter square, and My sprue area is 500 millimeter square, and my getting ratio is 2 is to 3 is to 1. My getting ratio is 2 is to 3 is to 1. So for example, if my sprue area is 500 millimeter square, so AS is 2 is to 3 is to 1. So AS is 2 times. So I can consider this to be 500 millimeter square. Since it is 3 times, so 3 by 2 of 500 would be 750, and 1 times, so it would be 250, because twice is 500, so 1 times will be 250. So from here what we can see, that this is the very smallest area, this is the very smallest and minimum area. So what we have defined, the choke area is defined as the minimum of the sprue, runner and the gate area. So from here we can say that minimum is 250, so my choke area will be gate area. So gate area will be my choke area, so I can write choke area is 250. So this is the concept of the choke area. This is the concept of the choke area, and this is the choke area, right? This is the choke area. What is the maximum volume? What is the maximum velocity here? What is the maximum velocity here? See here. We can see that this is the height of the pouring cup, and this is the height of the sprue, and total height is ht. So once I am pouring the molten metal from here, so I can see the maximum head is ht. Maximum head is ht. So velocity corresponding to the maximum head will give me the maximum velocity. Okay, so this V max is root over of 2g into ht. Next, what we have seen? We have seen a case of a bottom gate. In case of a bottom gate, we have derived the formula. See the V max, what I have told, root over 2g into ht. So this is the maximum head we can see, and the velocity corresponding to the maximum head will be Vmax. Now see, we have derived the equation for a bottom gate, and this is the pouring time equation for the bottom gate. This is the pouring time equation for a bottom gate. Now in this thing, we have assumed the Hc to be the total height and Hm to be the mold height. So in the first case, this was my mold height. Now there is a special case in which my Ht, that is the total height, becomes the mold height. See here. See, if my mold height, that is the mold cavity, is having the height of Hm of this much only, but I will increase the mold height. If I will increase the mold height, then my mold height is this Hm. Now you can see this mold height Hm is actually is equal to total height, and hence what a we can substitute in the formula is that Hm is equal to Ht. Clear? So Hm is equal to Ht. So once I will substitute that Hm is equal to Ht in this above formula, then what we are going to get, sir? We are going to get, sir, as T is equal to 2am AC 2G root 2G. We have seen these things in great details. Then we are getting the pouring time as is equal to 2 Vm AC by AC into Vmax. What is the Vm? Volume of the mold. Vmax, maximum velocity. Now if you will see this equation and you will see this equation, that is this, so you can find a similarity. This equation is actually is equal to twice of this equation, right? There is a twice, there is a factor, that is 2, right? So what we have found, the time required for a bottom gate is equal to twice into time required of a top gate. Condition applied. What is the condition, sir? Condition applied is that ht is equal to hm. Ht is equal to hm. Now, what is the parting gate? For the parting gate, we have seen, suppose this is the case of a bottom gate, and this is the case of a top gate. So what we are going to do? We are going to apply the formula of bottom gate. We are going to apply the formula of top gate for here. We are going to apply the formula for bottom gate here, and then we are going to add them. After adding, I will be getting the net pouring time for a pouring line gate. So this is what we have seen till now, and after that we are going to discuss some of the new important topics. Let us discuss those things, but before that let me check the comment box. If you have any doubt, then I will tell you. Okay, Mukta, I will try to arrange that. Okay, but abhi to nahi hoga. Maybe in near future I will do that. Definitely, no problem. अंकित जी, आइकॉनिक सब्सक्रिप्शन क्या है? अंकित जी देखिए इधर, in iconic subscription, In iconic subscription, you can choose your personal coach. This is much more important. So iconic subscription has the benefit of plus subscription, plus you can choose your personal coach. You can track your study performance and where you are lagging. Suppose your heat transfer is the problem, and in the heat transfer, suppose radiation is the topic from where you are getting a lot of bad marks, right? Here you are committing mistakes. So these things would be minute, and minute tracking would be there for person, that will be personalized for you. So this is the benefit of the study tracker would be there, like how you can improve the marks, where in which subject you are lagging, where exactly you are lagging. So these things would be tracked, as well as main question answer practice would be there. And see, along with the benefit of the plus, these are the things. So personal coach is like a coach. You can choose a personal coach to any educator whom you think that I have a good tuning with him, and that coach will help you throughout the preparation of GATE and ESE. And see, this iconic subscription is also for GATE and ESE. So there is a two in one, like pay for a one subscription and get the benefit of GATE and ESE. So this is what is the iconic subscription. Good evening, Samji. Good evening. Where parting gates are used. See, Indrajit, not every time we can make a top gate or a bottom gate, है ना? Sometimes that we find that with the convenience of the foundry personnel, right? Based on their experience, जब जब जिस चीज का जरूरत पड़ता है उस हिसाब से कर लेते हैं, ठीक है? तो based upon the availability, based upon the things we do, we use the parting line gate. जब बहुत दिक्कत होता है, जब छोटा साइज होता है हमारे पास और काफ़ी बड़ा डायमेंशन हो जाता है, पोप एंड ड्रैग का साइज बहुत छोटा होता है हमारे पास, और डायमेंशन जो प्रोड्यूस करना है उसमें बहुत बड़ा डायमेंशन प्रोड्यूस करना है, गेट बनाने में काफ़ी तकलीफ होता है। वो कभी कभी होता है कि जब हम बॉटम गेट बनाते हैं तो काफ़ी फ्रेजाइल हो जाता है चीज़, होल्ड कैविटी बिना सपोर्ट के कारण टूट जाता है। तो देर आर लॉट ऑफ थिंग्स आर देयर। सो these practices are done by the foundry personnel, totally based upon their expertise and the experience. Okay, so let us talk about our new topic. See, we have seen the getting system, right? So in this getting system, again, what we have seen, see here, this is the getting system that we have seen. This is the getting ratio. What is the getting ratio? AS is to AR is to AG. Clear? Sprue area is to runner area is to gate area. Clear? So this thing you just have to keep in your mind. And based upon that, we have the pressurized and unpressurized getting system. Just I am writing it. So pressurized getting system and unpressurized getting. So there are two types of getting system based upon what we have seen. And what are them? Let us see. Let us see. Let us see them one by one. So first point is, what is pressurized getting system? In this pressurized getting system, total cross sectional area decreases towards mold cavity. Towards mold cavity. In short, what we can say in this is that प्रेशराइज सिस्टम सर एक वैसा सिस्टम होता है जहां पर माय रनर एरिया इज ग्रेटर देन गेटिंग एरिया। क्लियर? So this is the pressurized getting system. Now, what is the unpressurized getting system? In this, the total total cross sectional area increases towards mold cavity. ठीक है. So in short, what we can say to this, we can say to this, just this will be the reverse, right? So I can write as gating area will be greater. Here gating area will be greater in runner area. So in GATE and ESE, in both the examination, a 1 marks question are asked. So what is a pressurized gating system? So in this questions, you just have to remember runner area is greater than gating area. And you, if you remember this, that runner area is greater than gating area, you will easily score a single marks. In the single marks question, 1 marks questions, these things are asked. What is unpressurized gating system? Unpressurized gating system means gating area is greater than runner area. So this 1 marks questions, in this 1 marks question, these things are asked. Next is what? Next point is what? What I want to tell you is this. Next point is there. Pressurized gating system is what? So in this gating system, बिफोर दैट लेट अस एज्यूम, अगर मैं आपको प्रेशराइज कर दूं, कैसे प्रेशराइज कर दूं? अगर मैं आपको बोल दूं कि सर आज के आज ही आपको इंजीनियरिंग मैथमेटिक्स भी फिनिश करनी है, हीट ट्रांसफर भी फिनिश करनी है, मैन्युफैक्चरिंग भी फिनिश करनी है, और इसके साथ स्ट्रेंथ ऑफ मटेरियल भी फिनिश करनी है आज के आज, मतलब आपके पास 6 घंटे है, बस 6 घंटे में कर डालो, तो यू विल बी गेटिंग इन द प्रेशर, आप प्रेशर में आ जाओगे. तो प्रेशर में मैं तो आपको ले आया ना. अगर आप सीरियसली मुझ पर बिलीव करोगे और मैं अगर बोल दिया कि आप 4 सब्जेक्ट्स को आज कर दो, तो आप तो प्रेशर में आ जाओगे, आप अपने तरफ से कोशिश करोगे. लेकिन जब आप कोशिश कर रहे हो, आपके पास वर्कलोड बहुत ज्यादा है, आप कोशिश कर रहे हो, आप प्रेशराइज हो रहे हो. जब आप प्रेशराइज होगे ना, तो आप गलत सलत काम करोगे. ठीक है, प्रॉपर एफिशिएंसी नहीं होता उसमें. तो प्रॉपर एफिशिएंसी नहीं होता तो आप करना कुछ चाहोगे, होगा कुछ. Similarly, in pressurized gating system, what is the process, sir? In pressurized gating system, you will pour the molten metal. See these arrangements you have done, right? See these arrangements you have done. What are the arrangements you have done? You have done the arrangement of metal plate, स्ट्रेनर, इम्प्योरिटीज आप हटा रहे हो, मेटल प्लेट डाल करके वेलोसिटीज कम कर रहे हो, बहुत कुछ कर रहे हो, स्कीम बॉब लगा रहे हो, इतना सारा काम कर रहे हो, लेकिन लास्ट में आप क्या कर दिए? आप पूरे गेटिंग सिस्टम को ही प्रेशराइज कर दिए. आप पूरे गेटिंग सिस्टम को अगर आप प्रेशराइज कर देंगे तो प्रॉब्लम क्या हो जाएगा? मोर टर्बुलेंस, मोर टर्बुलेंस एंड चांसेस ऑफ मोल्ड इरोजन, है ना. अगर मैं प्रेशराइज कर दूं तो आप उल्टा फुल्टा काम करोगे. एंड सी मोर टर्बुलेंस, बहुत टर्बुलेंट फ्लो होगा इसमें. इवन इफ आप इतना सारा प्रिकॉशंस और प्रिजर्वेशंस वाला मेथड आप लिए हैं, लेकिन फिर भी देयर वुड बी अ मोर टर्बुलेंस विद दैट, एंड हेंस देयर इज अ चांसेस ऑफ mold erosion. Clear? So there is a chances of mold erosion. But see, since the gating system is unpressurized, not in pressure, and hence there is a less turbulence. Less turbulence. So better to separate this. Clear? Okay. So this is the second point that we have. I hope कि second points में आपको समझने में कोई problem नहीं हो रहा होगा, because everything is very basic. Everything is very basic. Now third point is what? What is the third point? So what is the thing is, in this casting yield is more. I have already defined what is the casting yield. In this casting yield is more, and in this casting yield is less. See, in pressurized, अगर मैं बात करूं कि अगर आप किसी फ्लूइड को, अगर मोल्टन मेटल को आप प्रेशर से अगर देते हो, तो उस प्रेशर के कारण क्या होता है? उस प्रेशर के कारण उस फ्लूइड के पास इतना फोर्सेस आ जाता है कि वो कोई भी छोटे से छोटे जगह पर, छोटे से छोटे कैविटी पर भी वो आराम से घुस जाता है ना, क्योंकि उसके पास एक प्रेशर होता है. उसके पास एक फोर्स होता है, तो फोर्स ऑफ मूवमेंट होता है, जिसके कारण वो कोई भी छोटे से छोटे इंट्रिकेट कैविटीज में भी आराम से घुस जाता है। तो इसके कारण क्या होता है, कॉम्प्लेक्स कॉम्प्लेक्स एंड थीन सेक्शंस कैन बी सक्सेसफुली कास्टेड बिकॉज मोल्टन मेटल जो है वो आराम से घुस जाता है, बट हियर कॉम्प्लेक्स एंड थीन सेक्शंस may not be successfully casted. Now, one last most important thing is there. See, here, since it is at pressurized getting system, so most important line that I am going to write, that it is a as in the here reduction in aspiration effect. I have explained the aspiration effect like 4 to 5 times, right? So there is a reduction in the aspiration effect, and here more aspiration would be there, more aspiration. So what are the most key takeaway point from these pressurized and unpressurized getting system for your preparation of GATE and ESE? You always and always keep in your mind that this runner area is greater than getting area for a pressurized. First point, here getting area is going to be greater than this runner area. Second thing, next what you have to remember, is reduction in aspiration effect. Reduction in aspiration. Next, in this unpressurized nuclear system, more aspiration effect will be there. So till now, if you have any doubt, then please ask me, as I'm going to explain a lot of things from here now. Okay. Casting yield, can you explain once please sir? Casting yield क्या था sir? Casting yield क्या होता है? Let us see. Let us see what is casting yield. See here, in yesterday's class or in other class also we have seen, suppose this is my mold cavity. So this is the casting, right? This is the casting that I am going to produce. ठीक है, जब मैं आपको molten metal यहाँ पर pour करता हूँ, when I am pouring the molten metal in this mold cavity, and after the solidification, this part will also solidify, right? So apart from this casting, I am also getting this runner, I am also getting this casting. बट सी, मुझे तो सर ये कास्टिंग का ही चीज चाहिए ना, लेकिन इस कास्टिंग के साथ साथ मुझे सॉलिड मोल्टन मेटल जो है कास्टिंग करने के बाद वो गेट का भी मिलता है, रनर का भी मिलता है, और ना जाने कितने सारे एलिमेंट्स भी रहते हैं उसमें। तो आप सोचिए कि मुझे तो कास्टिंग चाहिए था 5 kg का, सपोज करें कि वॉल्यूम अगर है इसका तो 50 mm³ की वॉल्यूम की मुझे कास्टिंग चाहिए होती है, लेकिन फाइनल जो मुझे मिल रहा है वो मुझे 70 mm³ की मिल रहा है चीजें। क्यों 70 mm³ का मिल रहा है चीजें? क्योंकि गेट है उसमें सर, उसमें रनर है, उसमें और भी बहुत चीजें हैं, है ना? तो कास्टिंग यील्ड क्या होता है सर? वॉल्यूम ऑफ कास्टिंग आपका कितना हो गया बाई टोटल कास्टिंग, ठीक है? दैट इज नोन एज कास्टिंग यील्ड। कास्टिंग कितना हो रहा है, कास्टिंग यील्ड इज दिस, क्लियर? दिस इज द कास्टिंग यील्ड। Sir, please explain point number 4. Okay, Ashish ji, see if suppose like this, okay, Ashish ji has a lot of doubts. See here, if I have a cavity like this, if suppose if this is the my if this is my mold cavity, right? If let us assume this is my mold cavity, okay, let us assume like this. Better not to consider like this. Any some intricate shapes are there. So let us assume this to be my mold cavity. Now when you are pouring the molten metal here, so what happens if the getting system is pressurized, then the molten metal will easily flow into these thin and complex structures. Okay, so molten metal can easily flow into these thin and complex structures, and hence what happens, the complex and thin sections can be successfully casted with the pressurized getting system. But whereas what we find in unpressurized getting system, what happens that molten metal, even if molten metal, we pour the molten metal not easily flow through these things. It find very problem, like molten metal cannot reach into this. So like suppose that this much amount of molten metal has been solidified. Suppose this much amount has been molten metal solidifies. So due to this, what is the problem, this part, this much part, in up to this much part, my molten metal did not reach. Up to this much part, my molten metal did not reach. Up to this much part, my molten metal did not reach. So this is the problem that we face in the unpressurized getting system, and hence complex and thin sections may not be successfully casted. May not be successfully casted. That's what I have written. Successfully casted. It means like you can cast. See, you can cast like this, right? You will get like this, right? Section you will get like this. You can always cast, but see, itna nahi hoga. So this is not a successful casting, and hence this is what I have written. Clear? Any other doubt? जितने महानुभाव हैं यहाँ पर, कोई और डाउट्स हैं सर आप लोगों को? चलिए, I assume that you don't have any doubt. So So again, I am telling you one more thing, that these 2 points are very much important. First point is this. Remember this. This is very much important. And remember this. This is very much important. Clear? Very, very, very much important. So, so now if you have, suppose that if I have given you like 1 is to 2 is to 1. If I have written it 1 is to 2 is to 1, what is the meaning of that, sir? First of all, tell me what is the meaning of that. If I have written as 1 is to 2 is to 1, it simply means 1 is my AS, right? What is AS? AS is sprue area. 2 is what? 2 is AR, that is runner area. And 1 is what? 1 is my AG, that is gating area. Gating area. So now let us see one thing. So see, you can always remember like that. Uh, how I remembered these things, I'm just telling you. This is SRG. Okay, so you may not be the fan of Saruk Khan or any other persons, but for time being, let us consider that Saruk is there, right? So we say that Saruk Ji, right? Saruk Ji, or any other thing, SRG, right? SRG, right? We say that G is the like सम्मान देने के लिए बोलते हैं, तो SR एक person है जिनको मैं G बोल रहा हूँ, SRG, right? If you can remember this SRG, then you can say that getting ratio is nothing. Getting ratio is nothing. It is a ratio of SRG. S means sprue, R means runner, G is getting. Clear? So in this way, you can remember the things. And if you are a fan of a Saruk Khan, then definitely you will be able to remember these things, right? So now if we can say that 1 is to 2 is to 1 is there, 1 is to 2 is to 1 is there. So now what we can see from there, what we can say from there, this is the runner area. So we can say two parts is runner area, right? Two parts is runner area. So what I can say, it is 1 is to 2 is to 1. So from here I can say that 2 is the AR, 2 is the AR. Hence more runner area, more runner area, more runner area. So if runner area will be more, it simply means it is a pressurized getting system, pressurized getting system. Clear? So in pressurized getting system, I have told you runner area is more, runner area is more. So based upon that, in this concept only, there was 2 to 3 questions was asked from gate. Clear? 2 to 3 questions were asked from gate. Indrajit has told AS, AR, AG. Yes, Indrajit. Mukta told pressurized getting. What is it? Pressurized getting? What do you want? You want to repeat me? तो ये था सर अपना कहानी आ, इस चीज का। तो आपको ऑलवेज दिमाग में क्या रखना है, अगर मैं आपको इतना ही डेटा दे दूं, if I am giving you only and only this data, is that I have a getting ratio of 1 is to 2 is to 1. What is the meaning from that? I have to, मैं इससे क्या मीनिंग निकालूंगा सर? पहला मीनिंग मैं ये निकालूंगा दैट माई ए आर इज मोर, दैट इज ए आर, runner area is more, runner area is more. See here, if my runner area is more, if my runner area is more, it simply means that it is a pressurized getting system. If it runner area is more, it means it is a pressurized heating system, and hence my aspiration effect will be reduced. इन तीन चीजों को दिमाग में याद रखना है कि टू, अगर ये टू यहाँ पे ज्यादा कर दें तो रनर एरिया हो जाएगा, ये प्रेशराइज हीटिंग सिस्टम हो जाएगा, और इसमें एस्पिरेशन इफेक्ट क्या होता है? एस्पिरेशन इफेक्ट कम होता है, less aspiration effect. If less aspiration effect will be there, then more erosion would be there, more erosion would be there. See, just now we have seen. So these things just these things you have to keep in your mind, that mold erosion would be there here, and this will be no mold erosion. बस ये कुछ 3-4 पॉइंट्स हैं जो आप याद रखते हैं, आप बहुत सारे क्वेश्चंस को बना सकते हैं। ओके, ओके, सो ये था अपना गेटिंग सिस्टम का प्रॉब्लम्स था। तो अब चलते हैं कल की जो टॉपिक्स जो हमने की थी, क्या की थी, दैट इज द pouring time, pouring time in case of a bottom gate and a top gate, right? So let us try to solve one numerical. So just try a numerical this. Just try a numerical to solve this numerical, and then I'll discuss these things. Then I will discuss these things. You have a 2 minutes time. I'm giving you 2 minutes time. Try it. Give an attempt. If you can't solve it, no need to worry. I'm here for you. Okay. Meanwhile, if you have any kind of any doubt, you are most welcome to ask them. Dear friends, if you have any doubt, meanwhile, you feel free to ask the questions. And if you don't have any doubt, then also it's very good that you are a brilliant person. You don't have any doubt. Then try this question. Give an attempt. Give an attempt and tell me the answers. एनी आंसर्स? क्या बात है, समझ में नहीं आ रहा है क्या आप लोगों को? क्वेश्चंस नहीं समझ में आ रहा? B. Okay. 2.67. Okay. Okay. I'm very happy. I'm always very happy to see some of you like Indrajit, Gupta, Ashish, Shiv Kumar, Shivam, and one more Suvam is also there. So I'm very happy whenever you at least try. ट्राई करना बहुत इंपॉर्टेंट चीज है. ट्राई करें. गलत सही तो वो तो बात का चीज है ना? Okay, let me give you the brief uh, about this question. Okay, so in this question, this is actually previous year gate question. Okay, so in this question, indeed it has told C, Ashish A, Subham D. Okay, okay, good. At least you are trying. See here, what is being told in this question? The height of down sprue is 175 mm. What is a down sprue? Let me draw a sprue. So this is the sprue. Height of the down sprue is 175 mm and its cross section R at the base is 200 mm square. So this is the cross section at the base is given. Clear? This is the cross section at the base. Here is a runner. Here is a runner. And what is being told that cross section at the base is 200 mm square. Cross section area of the horizontal runner is also 200 mm square. So suppose that what I can say that cross sectional area of runner is also 200 mm square, and this is also is equal to cross sectional area of sprue. Clear? Now see what I can say that assuming no losses indicate correct choice for the time required to fill a mold cavity of volume this much. So I do not know about that whether gating system is bottom or top or anything. So let us consider that gating system is top, and for this kind of situation is there. This kind of situation is there in which its volume is given as 10 to the power 6 mm cube. So this is the mold cavity, and from this mold cavity you are filling the this molten metal. Clear? So now how you can find the okay. So just let me draw it very fast. I don't know what just this is the sprue, this is the runner, and with this runner there is a volume, right? So this, what is this much amount, what is this height? See, height of the downsprue is 175, so I can draw height as 175 mm. Clear? This area and runner area, so I can write area of runner is equal to area of sprue is equal to 200 mm square. What is the volume here? Here the volume is 10 to the power 6 mm cube. Clear? Now see here, it has been told that what would be the time required to pour a molten metal. So when you are pouring the molten metal here, so what is the time required to fill this mold cavity? What is the time required to fill this mold cavity? How you can find the time required to fill this mold cavity? See, volume is given as 10 to the power 6 mm cube. Volume is given as 10 to the power 6 mm cube. So can you say anything about the this velocity? What would be the velocity through which this flow would be there? किस velocity से flow होगा? क्या आप कह सकते हैं किस velocity से flow होगा? We can say that this is 175, so we can say that this is 1.175 meter. Now if we will go for a velocity, see, the velocity, maximum velocity will be this is the maximum velocity, v max. So my Vmax would be, this is my HT, total height, clear? This is my total height. So we know that Vmax is equal to root over 2g HT. Now if I will do the calculation, that would be root over 2. It is given that use 10 in place of g, so 10 into HT. What would be the HT? HT is 0.175. Now if you will calculate, you will get the maximum velocity is equal to 1870 by 1870 mm per second. This is the maximum velocity that you are going to get. Now see, I know the maximum velocity. I know the maximum velocity is this. So what is the time required? What is the time required? We have seen time required as volume of the mold by choke area into maximum velocity. Clear? So, so pouring time is equal to volume of mold by choke area into maximum velocity. So pouring time will be what? What is the volume of mold? Mold volume is 10 to the power 6 mm cube. What is the choke area? See, since only two areas are given to me in this question, that is the sprue and the runner, and both are actually same. So see, I can say that both area are same, so minimum or maximum both are same. So let me consider the 200 to be a choke area. Clear? So the choke area would be 200 mm square. And what is the Vmax? Just now we have calculated the Vmax as 1870 mm per second. So 1870. सो नाउ इफ में आ जाएगी तो वो भी आपको बहुत आसान लगेगा. Asis, see, you can do the calculations in that also. See here, here I have done the calculations. See here I have done the calculations in the SI unit, right? So there is a meter per second, and I have converted this into the meter. But later on, I have changed into the mm per second, because what we are desired here, it is mm cube, mm square, mm. So like better to say like after that conversion is there, so that everything will get cancelled. Okay, for ease, right? For ease, you can feel free to use anything. ठीक है सर. तो ये क्वेश्चंस आपको समझ में आ गया होगा. आई थिंक यू हैव understood this question, and whosoever has given the option A as the correct answer, so you are giving the correct answers like Indrajit, Mukta, आशीष. ठीक है, समझ में आ गया होगा आपको ये क्वेश्चंस. ठीक है, चलिए और एक क्वेश्चंस को एक बार देख ही लेते हैं, उसके बाद मूव करते हैं एक और चीज. Suppose in a sand casting, a sprue of 15 mm base diameter and 300 mm height leads to a runner with runner which fills cubical mold cavity of 150 mm height. The mold filling time in second is. Tell me the answer. Tell me the answer. Try to solve this question and tell me the answer. So there is a sand casting process, and in the sand casting process, a sprue of 15 mm base diameter is given, 300 mm height is given, and after that cavity mold cavity of 150 mm size is given. So there is, in this question it has been asked, find the mold filling time. Find the mold filling time. One more announcement that I want to make. Unit 2 second होगी ना टीपी की. टीपी की सेकंड यूनिट. हाँ जी, बिल्कुल बिल्कुल. ओ सॉरी, Thank you so much. Thank you so much. Thank you so much, Shivam Sahu. Thank you so much. 7.872। ओके, और भी लोग बताएं। और जो मैं एक अनाउंसमेंट करने वाला था कि फ्रॉम द मंथ ऑफ अक्टूबर, लाइक फ्रॉम द मंथ ऑफ अक्टूबर, फ्रॉम 5th of October onwards, I will be starting a crash courses। ओके, मैं कुछ क्रैश कोर्स स्टार्ट करूंगा। क्रैश कोर्स बेसिकली दैट विल फोकस्ड ऑन प्रोडक्शन इंजीनियरिंग। ठीक है, प्रोडक्शन से ही मैं क्रैश कोर्स कुछ करने वाला हूँ, स्टार्ट करने वाला हूँ, जिसमें टॉपिक्स को लूंगा। तो इफ़ यू हैव एनी सजेशंस दैट व्हाट शुड आई डू, प्लीज let me know, and accordingly I will frame the subjects. I will accordingly start the crash courses. Okay, try to solve this question. So this height is given, 300 mm height is given, sprue of 15 mm base diameter is given. So this is a sprue. For example, the sprue has a base diameter of 15 mm, and this is a cubical mold. This is a cubical mold whose size is given as, suppose the size is A is given as 150 mm. Yeah. And from here you have to calculate the mold filling time. Assays, maybe like when I will be doing the crash courses, then I will try to finish this casting। ठीक है, मैं कास्टिंग तो कंप्लीट कर ही दूंगा, उसके बाद जो है मुझे क्रैश कोर्स करना है। तो आई होप इन दैट क्रैश कोर्स आई विल टेक द अदर टॉपिक्स अपार्ट फ्रॉम दैट मेटल कटिंग एंड द कास्टिंग। ठीक है, मैं उन सारे टॉपिक्स को ले लूंगा क्रैश कोर्स में, because after that maybe this class will be discontinued and only crash course would be there। ठीक है, तो क्रैश कोर्स में मैं उसको ले लूंगा। मेटल कटिंग और कास्टिंग तो मैं ऑलरेडी करवा दूंगा यहाँ पर, वहाँ पर बचे कुचे जो कसर होंगे वो कर लूंगा वहाँ। एंड एक और सर जो है वो आपको पढ़ाएंगे डिफरेंट डिफरेंट सब्जेक्ट्स। तो प्रोडक्शन, कैन यू स्टार्ट इंडस्ट्रियल इन दैट कोर्स? इंद्रजीत, एक्चुअली फॉर इंडस्ट्रियल और भी सर हैं जो पढ़ाएंगे आपको इंडस्ट्रियल, but for that once the strength of material is finished in the Unacademy learning app, so in the Unacademy learning app I can start the industrial, or if you want to me to if you want me to continue like building and these things, so I will continue at the Unacademy learning app। Is it good for you? चलेगा? 7.8726, 5.47, चलिए देखिए, देखते हैं, let us see, let us see। So see, this is a cubicle. This is a cubicle cavity is there. A is given as 150 mm. So what I can say that volume would be 150 cube m cube. Clear? This is my volume. This is my volume. So volume is this. Now if I will write the velocity, so what would be the maximum velocity? What would be the maximum velocity at this case? So maximum velocity would be root over of 2 GHT, root over of 2 GHT, and which is actually 2 is G would be what? G would be 9.81, and what is the HT? HT will be 0.3. HT will be 0. Clear? So V max is going to be is equal to V max will be 2.4. 2.4. Now see, what is the time required? So time required, I can say that 0.15 whole cube. That is the volume. Volume by area. If I will do it, so like what is the area? Area would be pi by 4. This 15 mm is given, so 0.15 whole square. This is my area into my 2.42. So this is the maximum velocity, 2.42. Now see what we have learned earlier in the earlier sections. What we have learned, if we want to calculate T, that is the V of mold by AC choke area into V max. So you can see how you are applying these formulas, because see, if in the question it has been nothing, it has been mentioned about that whether it is a top gate or a bottom gate, always consider this to be a top gate, always consider this to be a clear. Now just a rudimentary calculations purposes are there, so for this you will get the value as 7.827. So till now if you have any doubt, then ask with me. कोई doubt है क्या sir? Any doubt? If you have any doubt, then please ask with me. So this much length is suppose 15 is given. This much length is 10 is given. This is HT. So suppose this HT is given as this. Okay. Now, if this is a configuration, then you have been asked to calculate cross-sectional area of gate. First point is there, calculate cross-sectional area of gate such that liquid metal can be filled into the cavity in 10 seconds. So here the pouring time is given, and from the pouring time you have to calculate the cross-sectional area. So can you calculate this? Try to calculate this. ओके आशीष, आई विल ट्राई। देखिए, अगर अगर यूट्यूब पे नहीं होता है तो आई विल बी टेकिंग दीज थिंग्स इन द अन अकेडमी लर्निंग ऐप, राइट। मैं फिर ऐप पर ले लूंगा क्लासेस, डोंट वरी। ठीक है ना। तो ट्राई टू सॉल्व इट। ठीक है आशीष जी, जो भी होगा मैं करूंगा। सो टेक दिस क्वेश्चन एज अ प्रैक्टिस क्वेश्चन फॉर यू गाइस। टेक दिस क्वेश्चन एज अ प्रैक्टिस क्वेश्चन। प्रैक्टिस दिस क्वेश्चन, वेरी गुड क्वेश्चंस आर देयर। हम्म इसमें मैं बता देता हूँ, गेटिंग एरिया का आंसर जो होगा वो 6.05 सेंटीमीटर स्क्वायर होगा। ठीक है, चलिए। सो दिस इज द थिंग, गिव a try, give a try at your home, and this is the practice questions that you have. Now for today's session, what is the new thing that I'm going to start is the total solidification time. Total solidification time we are going to start. See here, what is total solidification? Total solidification time. Total solidification. So for a total solidification time, what happens that uh, कितना टाइम लग रहा है मुझे सॉलिडिफिकेशन में, है ना। सिंपल भाषा में अगर मैं समझूं कि सॉलिडिफाई करने में, जब मैं मोल्टन मेटल को पोर कर चुका हूं तो सॉलिडिफाई करने में कितना समय लग रहा है, ठीक है। व्हेन आई हैव पोर्ड द मोल्टन मेटल, हाउ मच टाइम this molten metal took to solidify in that mold cavity, that is known as total solidification time. Now there was a one scientist, whose name was Chavorniv's rules. Okay, so Chavorniv's rules, so we can say that Chavorniv's rules. Okay, so from this Chavorniv's principle we can say he has given the one principle, and that principle is total solidification time, that is TST. Total solidification time is proportional to V by SA square, or better to say as N. First of all, better to say as N. Clear. So here this is N is the index. So let me define what is TST. TST is total solidification time. Total solidification time. Next, what is next? V is what, sir? V is the volume. What is SA? SA is the surface area, and this N is the index. Generally it is considered to be a 2. So now if this is the formula, so what I can say here, TST is equal to some constant K. We know that whenever I remove the proportionality sign, then for that I have to give a constant. Okay, so this is my constant K into V by SA, that is square. Clear. So this is the formula V. So this is the total solidification time that we are getting. Clear? So now this is the total solidification time that we are getting. Clear? And apart from that, what is a K? What is a K? K is a solidification factor. Solidification. Okay, so K is a solidification factor. So this is what is the Cherepov's rules says that to find the total solidification in any mold cavity, so we have to take the volume of the mold cavity, surface area of the mold cavity, and once we know these things, we will put in this equation and we will be getting the total solidification time. Clear? This is the total solidification time. कोई प्रॉब्लम, कोई दिक्कत अभी तक? कोई प्रॉब्लम? If you have any problem, then ask me. So now let us see one more thing. Okay. So now see this thing we have seen. This thing we have seen that total solidification time is this. Total solidification time is this. Total solidification time is K into V by SA whole square. Remember this formula. This formula is your bread and butter for your gate. क्लियर? दिस इज योर ब्रेड एंड बटर फॉर योर गेट. सर गेट में आपको रोटी चावल दाल सब्जी सब कुछ आपका यही है, यही सब चीज आपको मार्क्स दिलाएगा, तो इसको आप एकदम याद कर लें. ठीक है, दिमाग में गांठ बैठा लें. टोटल सॉलिडिफिकेशन टाइम इज इक्वल टू के इंटू वी बाई एस ए स्क्वायर. नाउ लेट अस सी समथिंग दैट इज कॉल्ड एज टाइप्स ऑफ सॉलिडिफिकेशन. Types of solidification. What are the types of solidification? For solidification, first type is first type of solidification is skin forming, and second type of solidification is dendrite dendritic growth. Dendritic growth. So this is visible to you. So see what is skin forming. What is skin? Suppose what is the skin forming that so this type of solidification takes place in either the pure metal or in the alloys, right? So suppose I am writing this takes place in either in pure metal or in pure metal or in alloys, these things are happened. And see what actually is the problem, what is the thing happening. The solidification the solidification the solidification front will move towards center, and solidification appears layer by layer. Layer by layer, what does it mean? Suppose if I have this kind of mold cavity and I am having a casting and I'm doing a casting, then I'm getting the things in like this fashion. Layer by layer is there, like so this is one layer, like this, like this is the one thing, right? So towards the center, the solidification front will move towards the center. So this is my solidification front, right? And the solidification front will move towards the center like this. Solidification will move like this. So it will front will move like this. This is my center, right? This is my center. So this in this way my solidification front will move like towards the center, right? So it is moving towards the center. So this is how the actually forming is there, and see the solidification takes place in this type, like layer by layer, and hence they are forming a skin. They are forming a skin, and hence it is known as skin forming. So this is a beautiful type of a solidification in which we have seen the skin forming. Next is the most thing important. uh, any doubts? Caution when we notes. What do you want notes? You can make the prepare the notes whatever I am teaching to you. Next is the dendritic growth. Okay, so what is the dendritic growth? What is the dendritic growth? So before starting the dendritic growth, we must know that if mushy zone appears during the solidification of Ly, right? So initially a solid the nucleus near the boundary, and solidification from move towards the center. So for what I can say here, if I will draw this, if I will draw a mold cavity, then what kind of thing is there? Suppose there is a uh, so suppose that what happens, that solid will also form nucleus. Suppose that here also you are getting something. Okay, so solidification is like in dendrite. Dendrite means like sections, some small sections. In this way the solidification is there, like this, like this, like this. So like this is the one part, right? And like this, they are achieving to the center, like this. They are like moving like a small dendrite thing. So this is called dendrite, right? So for example, there is another dendrite like this, like this. So this is also the another dendrite. So the solidification takes place in this fashion, and they are reaching to the center. That is known as dendritic growth. That is known as dendritic growth. So this much you. Thank you, Aman, for such a beautiful words. Thank you so much. These words really motivates me. So this is the dendritic growth, right? So this is the dendritic growth. So I think the types of solidification clear to you, है ना? मेन एम क्या होता है सर? मेरा मेन एम होता है कि मैं सेंटर को अप्रोच करूं, मैं सेंटर को अप्रोच करूं, मैं सेंटर को अप्रोच। कैसे सेंटर को अप्रोच करूं सर? अगर सॉलिडिफिकेशन कुछ इस तरह से होता है तो मैं सेंटर को अप्रोच कर रहा हूँ। सॉलिडिफिकेशन अगर कुछ इस तरह से होता है, मैं सेंटर को अप्रोच कर रहा हूँ। ठीक है, so this is what is the thing. Next thing that we should do is, suppose that we have seen a total solidification time. For total solidification time, let us try to solve the total solidification time for a cube. So suppose if I have a cube, like this. So suppose I have a cube like this, whose length is given as a. Okay, so now what is the total solidification time? So for this I can say that volume would be a cube. What would be the surface area for this? Surface area would be 6a square. If this is the a is the length of the cube, then volume is a cube, surface area is 6a square. So if this is the given, so see what is the formula that we have seen for a total solidification time. That total solidification time is equal to k into V by SA whole square. Clear? So now if I will put these things here in this, then I will be getting as, what is the V by SA? V by SA is V is given as a cube, SA is given as 6a square. The ratio is going to be is equal to a by 6. This is the ratio, right? So if I will talk about the total solidification time, would be a into V by SA whole square, and hence total solidification time would be K into A by 6 whole square, which is KA square by 36. This is my total solidification time for a cube. Okay, for a cube. Yes, yes, Subham. Solidification starts from the edge and proceed to the center. See, from here you can see this is my edge. So it is starting from the edge and reaching the center. This is a starting from the edge and reaching to center. Yes, we can say. Can say. So this total solidification time for a cube, this is clear to you, sir? Clear है? I hope that is clear to you. ठीक है, तो चलिए नेक्स्ट हम देखते हैं टोटल सॉलिडिफिकेशन टाइम. टोटल सॉलिडिफिकेशन टाइम. Total solidification time for a sphere. Now for a total solidification time for a sphere, so suppose this is my sphere and this sphere is having some radius r. Okay, so what would be the volume of this? What would the volume of this sphere? So I know that volume is pi by 3 pi r cube, right? Pi by 3 pi r cube. So this is the volume. And what is the surface area? What is the surface area? Surface area is 4 pi r square. 4 pi r square. So now if I will do that V by SA, what will the V by SA? V is 4 by 3 pi r cube and SA is 4 pi r square. So what I am getting as this is going to be is equal to r by, clear, r by 3. This would be r by 3. Now see, this is r. So what we can say that this is diameter is equal to 2r. Diameter is equal to 2r. So this can also be written as d by 6. So v by SA is nothing but r by 3 or d by 6. Next, how we can find the total solidification time? For a total solidification time, we know that it is nothing but k into v by SA whole square. And what is this? And we will calculate this. This would be k into volume. V by SA square is given as d by 6. So I will say d by 6. D by 6 whole square. And hence we are getting total solidification time as k d square by. ठीक है, ये मुझे मिल रहा है टोटल सॉलिडिफिकेशन टाइम. कोई दिक्कत? नेक्स्ट अगर मैं देखूं, so this is the first case was there for a cube. So for a cube is there, this is the total solidification time for a cube. For a cube, next we have seen a total solidification time for a sphere. Total solidification time for a sphere. Next what we are going to see, total solidification time. Total solidification time for a cylinder. Total solidification time for a cylinder. So total solidification time for a cylinder is what? If we are taking a cylinder, suppose this is a cylinder which is having these things are there. Suppose the base is there, so base is having, so these base has having a diameter. Suppose this diameter is d and this height is h. Okay, this height is h. Now see, these two things are known to us. So what is the volume? What is the volume? We know the volume is going to be is equal to pi by 4 d square into h. Clear? The volume of cylinder is pi by 4 d square into h. Now what would be the surface area, sir? What would be the surface area? See, surface area would be what? Surface area would be what? See, pi by 4 d square. These are the two things. These are the two things. So for this and for this, for these two surfaces, for these two surfaces, for these two surfaces, that would be twice into pi by 4 d square. Clear? And for this curved, for this is the curved, right? So this is the curved surface area. This is going to be the curved surface area. So for this, my area will be pi dh, pi dh. So once these things are clear to you, just apply this. Just apply this. V and SA is given to you. So what would be the ratio of V by SA? The ratio of V by SA would be pi by 4 d square by h, d square into h. This is equal to twice into pi by 4 d square plus pi dh. Now see here. Now see here. Here pi, pi, pi. This will be get cancelled out. See, this is d square. So what I can say, 1d would be there, the 1d would be there, and 1d would be there. Clear? So now what we are left with on the above is that this is what we are left with as dh by d plus of 4h. Clear? 4h. So we can write like that: volume by surface area ratio is dh by d plus of 4h. D plus of 4h. So if this is okay to you, then total solidification time will be what? K into V by SA whole square. So what would be my total solidification time? That would be K into V by SA is given as DH. So DH by D plus 4H whole square. Yeah. Now this is going to be my total solidification time. These things you just have to remember. That is A dh whole square by d plus 4h. Okay. So this is what is the total solidification time. I hope you are getting the logic and the concepts are clear to you, right? Formula based things are there, but yes, very much important. Now next case, if I would take, next case would be total solidification time. Total solidification time for a slab, now we just have seen the cases of a sphere, cylinder, cube, right? Now just take a case of a slab. For example, what is a slab? For example, slab is like this. Just a minute. So this is my slab, right? So this is my slab, and suppose the length is L. This is the length L. Clear? And this is, oh, this is given as B. Yeah. So this, let this to be a B. And what is this? H. This is height. This is H. So this is the dimensions given for a slab, and if I'm interested to find the volume for this, corresponding to volume for this, what would be my volume? Length into breadth into height, right? LB into H. Now what would be the surface area corresponding to it would be there? So surface area, I can say that twice into L, right? So these things are clear to twice into LB plus BH plus HL. This is my surface area. Now if again I know the volume and the surface area, let us find the ratio of V by SA. So I know this LBH twice of LB plus BH plus HL. So from here, what I can say, this is my V by SA ratio. Again, what would be my total solidification time? K into LBH by twice of LB plus BH plus H, right? So this is the whole square. So these things are there for you. So for these cases, try to remember these things, or even if you don't remember these things, just keep these things in your mind that V by SA ratio would be this, total solidification time for the case of a slab would be this, total solidification time for a case of a slab would be this, and total solidification time for a cylinder would be this. This is the formula for total solidification time for a cylinder. Okay, and this is my V by SA, right? So this is my V by SA, this is my V by SA, just to keep these things in your mind. Next, what we have seen for a sphere, right? So for a sphere, V by SA is R by 3 or D by 6, R by 3 or D by 6. And what is the total solidification time? We have AD square by 36, AD square by 30. These things we have seen. Next, what is we have seen for a cube? V by SA, V by SA is A by 6, V by SA is A by 6, and total solidification time is A square by 30, A square by 30. So I think these things are clear to you. If you have any doubt, ask with me. I am waiting for your reply. Okay, is there any problem with that? For a cylinder, I have to check the total solidification time. Okay, so okay. So see, what I can say here is that we have let me calculate it. So I am having dh by 4 or 2d plus of h. Okay, so say that dh by 4, that is 8d plus of 4h. Okay, okay, so I'm getting like this, right? I'm getting like this. Okay, no problem. So that is 8d would be there, so 8d plus 4h would be there. Hmm. Okay, so 8d plus 4h, so just substitute these things. 8d plus 4h would be there, and from here this would be 8d plus 4h. Okay, now it's clear. This would be d by 2 would be there here, d by 2 would be there, and this is h, right? So after that you will be getting as this would be 2d plus of 4h, right? 2d plus of, yes, 2d plus 4h would be there. So just replace the 2d, replace it with the 2d, replace with the 2d. Okay, now it's okay. Now it's okay. Any other queries? Any other queries, sir? Thank you so much. Any other queries that till now what we have seen? Hmm? Tell me if you have any queries. If you have any problem, then tell me. And if everything is clear, then I'll proceed to the next thing. I'll proceed to the next thing. Okay. Okay, so I'm proceeding to the next part. Okay, so I'm proceeding to the next part. What is the purpose of riser? Vivek Soni, yes, I have. What do you have problem, Vivek sir? Tell me. Tell me. Ask me the question so that once I will take your doubt, then I will start this topic. हम्म क्योंकि बीच में फिर आपका डाउट आ जाएगा तो फिर मैं डिस्टर्ब हो जाता हूँ. If you have any doubt, then ask me. I'm giving you a time. Okay, then I'm assuming that don't have any doubt. Okay, I'm just continuing these things. Okay, so I'm continuing with the topic. Purpose of riser. What is the purpose of riser? So see, the first purpose of riser is provided to compensate liquid liquid and solidification shrinkage. Let me draw it for you. Vivek Soni, what do you want to elaborate me? These things, total solidification time. Just put the things. If you want me to elaborate the total solidification time, then tell me. Then just let me know so that I will do it. No problem. So now, first I will describe this and then I will do it. If you want, then just let me know. Just give me a comment so that I will be understanding the problem of you. Okay, so now see, riser is provided to compensate the liquid and the solidification shrinkage. So suppose this is my casting. So this is my casting, right? So this is my casting. This is my mold cavity, right? So in this mold cavity, suppose in this mold cavity, what I am doing, sir, I am putting the riser on the top. Remember, if I am putting the riser, that is the, if I am pouring the molten metal from the sprue, right? Suppose like the sprue is there. These things I'm not drawing, but still I'm just drawing for you so that you can understand, right? So suppose you are pouring the molten metal, right? Suppose you are pouring the molten metal. So from here molten metal is coming. From here molten metal is coming, right? And this molten metal is coming and filling this mold cavity, right? Just filling this mold cavity, as well as this mold cavity is filled, as well as uh, this is the riser, riser is also filled with the molten metal. So now, since the riser is on the top of the mold, since riser is on the top of the mold, hence it is known as top riser. Hence, riser is on the top of a mold cavity. Hence, it is known as top riser. Clear? So there is a type of a riser. Riser type is top riser. First is the top riser. Now, what is the use is that, see, since in this I am pouring the molten metal, and see, suppose this is in liquid state. This is in liquid state. Once it will solidify, then what will happen? It will shrink, right? It will shrink, and once it will then what will happen? This riser will provide the molten metal from here. Riser will provide the molten metal from here to the mold cavity, and hence it will compensate the liquid. So what I have written, riser is provided to compensate the liquid and solidification shrinkage. Clear? I think this point is clear to you. right? Now the see, based upon the position of riser, there are the names, right? Suppose if the this is my mold cavity, and in this mold cavity, if I am placing the riser to be here, suppose my riser is like this. Okay, so my riser is like this. If I'm placing the riser inside, so since see this riser is on the side, so I can say this is my side riser. If riser will be inside the mold cavity, suppose like this, I make the arrangement in which, like, you cannot see that riser, it will be inside. So in that cases of thing, this riser is known as blind riser. Blind riser means what? We cannot see it, it is blind. Hmm. The most important among them is these two things. From these two things, questions in GATE and ESE are asked a lot. Top riser, we are going to solve these things also, no need to worry. Now, second point is the first point is the riser is provided to compensate the liquid and solidification shrinkage. Now, the that second point is that it is used. It is also used to check whether mold cavity is full or not. Clear? Whether it is mold cavity is full or not, right? अगर full होगा तो ठीक है, नहीं full होता है, इनकम्प्लीट होता है, तो यहाँ से क्या होता है हमारा, यहाँ से हमारा मोल्टन मेटल अंदर की तरफ जाता है, ठीक है, कंपनसेट होता है, समझ में आ रहा है, कंपनसेट होता है. Now next, what is the most important point? So what we have seen that riser design should be such that it solidify, right? These things we have seen in earlier classes. I have told you that riser should solidify after the casting. Why after the casting? So that liquid metal is available, to compensate shrinkage. ओके. सो दिस इज मस्ट मोस्ट इम्पोर्टेंट, है ना, कि अगर मान लें यहाँ पर आपका राइजर में जो मोल्टन मेटल है फ्राई कर गया, ठीक है, तो फिर भाई अगर यहाँ पर श्रिंकेज जब होता है तो उसको सप्लाई कौन करेगा, है ना. सो इन इंग्लिश दैट if what will happen that here in this place, suppose in this place, so you have filled the molten metal into this mold cavity, right, and in this molten metal is also in the riser. Now suppose if a condition would be there, in that condition whatever the molten metal in the riser is there, so it will solidify first, and after that my molten metal in the mold will solidify lastly. Then what would be the problem that we have to face? See, what is the main sole purpose of this riser? Sole purpose of this riser, sir, that if there would be any problem, that any shrinkage or solidification or compensation of the liquid is there, so I can compensate from the riser. But see, if riser will solidify first and then mold, then this problem would be there. I cannot compensate. So there is a necessity that this riser should solidify after the solidification of casting. So can I say that a riser will take a lot of time to solidify, right? I can say that riser will take a lot of time to solidify compared to the casting. So I can say that total solidification time for the riser should be greater than total solidification time of the casting. Clear or not? Give me a thumbs up if this concept is clear or not. The total solidification of the casting is should be less than total solidification of the. So this thing I can write that riser should be designed, right? So let me write it that riser should be designed. Riser should be designed in such a way that it has minimum surface area, as well as what we have seen that total solidification time for the riser should be greater than total solidification time for the casting. And see, total solidification time for the riser is greater than total solidification of the casting. So can I say that K into A by V of the riser would be greater, right? So these things are important. So what I can say that volume of riser is equal to 3 into percentage of shrinkage volume of casting. So having known these things, and somebody was telling me that I should repeat these things. Who was that? Vivek Soni sir, आप तो फिर कुछ reply नहीं दिए मुझे. Okay, so for Vivek Soni sir, I'm just giving a quick revise, and you all please also see there that what I have written here, there is a total solidification time, right? There is a total solidification time, and this great scientist Chevornivos, what he did, he given a formula of total solidification time is proportional to V by SA. What is V, sir? V is the volume of the mold cap. What is SA, sir? SA is the surface area of the mold cavity. Better not to write mold cavity to make it generalized, right? To make it generalized, let us write V and SA. So what I can say here, the total solidification time is this. V is the volume, and SA is the surface area, and N is the index, and it is actually 2. K is the solidification factor. What is the total when we will replace this, when we will remove this proportionality sign, then I will be getting as K into V by SA whole square. And what is K? K is the solidification. Now after that, one by one we have seen the types of solidification: skin forming and a dendrite growth. In both the cases, what we have seen that the formation is moving to the center. It is approaching to the center. After that, we have seen a total solidification time for a cube. So in this, if this is a cube and it is having a length A, then volume would be A cube. Surface area would be 6A square. Then V by SA will be what? A cube by 6A square. That is A by 6. Then I have found the total solidification time is equal to K into V by SA whole square. V by SA ratio is A by 6. So just A by 6 whole square, and hence I got total solidification time is equal to K square by 30. Next, what we have got total solidification time for a sphere. Total solidification time for a sphere. So first step is, what is the first step? First step is that this is my radius, right? Radius is R. So what is my volume? Volume will be 4 by 3 pi r cube. What would be surface area? Suppose if this is my radius, R is there, so diameter is equal to twice R, right? These things we know. R is square. So V by SA would be 4 by 3 pi r cube by 4 pi r square. Cancel out and you will get R by 3, and replace this relation D is equal to twice R. Hence you are getting D is equal to D by 6. So what is the thing that we are getting is that V by SA, volume by surface area, this is actually is equal to R by 3 or D by 6. Now, having known this ratio V by SA, let us put this ratio here. Total solidification time is equal to K by VA square, and V by SA is D by 6. Let us consider D by 6, and hence I am getting this formula. Total solidification time for this case of a sphere is KD square by. Now, Next, what we have got? We have got total solidification time for a cylinder. So for a cylinder, volume would be pi by 4d square into h. Volume would be pi by 4d square into h. And what about the surface area? So their total surface area would be what? So surface area would be curved surface area plus this. On the upper part of there is a circle, the lower part there is circle. So for both the cases, that would be twice into pi by 4d square plus pi dh is the curved surface area. Right. So based upon that, if I will put these values here, then I have got the things, right? So suppose like this, total solidification time is equal to k into dh square by 2d plus 4h. So this is the formula of the total solidification time that we have got. Next is total solidification time for a slab. For a slab, this is a slab of length L, breadth B, and height h. So how we can find the volume? Volume we can find by V is equal to LB into H. And surface area is what? Twice into LB plus BH plus HL. So this is the surface area. If when I will do the ratio of V by SA, then I will get as LBH by this, and hence I will be getting as K into LBH twice LB plus BH plus HS whole square. So this is what is I have discussed with you till now, the things. So I don't think you have any doubt till now. So let us try to solve one important thing. Thank you, Syam. Syam Babu, thank you so much. शिवम थैंक यू सो मच. माई मेरा कोशिश यही होता है. माई ऑलवेज आई ट्राई माई लेवल बेस्ट. ऑलवेज आई ट्राई माई लेवल बेस्ट टू गिव यू द बेस्ट थिंग. साइन उल्टा हो गया. वेयर साइन? कहाँ पर साइन उल्टा हो गया मुक्ता जी, मुझे बताएं. टेल मी. चलिए 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 एक जल्दी जल्दी से क्वेश्चन देख लेते हैं, ठीक है. लेट अस सॉल्व वन क्वेश्चन सो दैट वी विल व्हाट एवर वी हैव लर्नड टिल नाउ, हम उसको अप्लाई करके देखते हैं, बिकॉज एप्लीकेशन पार्ट इज वेरी मच इम्पॉर्टेंट, और एप्लीकेशन पार्ट ही हमें सब कुछ बताएगा. सपोज आई एम जस्ट राइटिंग अ क्वेश्चन. Three metal piece three metal pieces being cast have the same volume. Okay, have the same volume but different shapes. One is sphere, one is a cube, and is other is a cylinder. Okay, other is a cylinder with its height equal to its diameter. Okay, so in this question it has been asked which piece will solidify the fastest and which one the slower. Which one will the slower, right? Slower. Tell me the answer. Try to solve this question. Try to solve this question. Try to solve this question and tell me the answer. Please clear my doubt. Okay. What is your doubt? See here, सभी लोग मुझे यह बताएं. Everyone, please tell me that whether my riser should solidify first or casting should solidify first. Tell me. Tell me whether casting should solidify first or riser should solidify first. Everybody, please tell me that casting should solidify first or riser should solidify first. Mukta, tell me. You have the problem. If you will think like that, uh, casting will solidify first, right? So casting will solidify first. So if casting will solidify first and then riser will solidify, then can I say that if casting will solidify first, then solidification time for casting will be less, solidification time for riser should be more, right? Because थोड़ा बहुत देर के बाद वो solidify हो रहा है ना. So we can say that total solidification time for riser should be greater than total solidification time for the cast. Clear? So now I have given you the question. Try to solve this question. Try to solve this question, and you will be able to understand these things. Okay. Hmm. Try to solve this question. Try to solve this question. See, I'm just explaining this question that three metal pieces being cast have the same volume, right? So volume is same. The first thing is there, volume is same but different shape. One is sphere, one is a cube and other is a cylinder. Clear? So three things are there: cube, sphere and cylinder. So what we can say, with its height equal to diameter, so I can say that volume is same, height is equal to diameter, right? And what are the cases? First case is the sphere, next is the cube, and third is the cylinder, right? So can I say that if this is the cases, then if this is the cases, then I can say that total solidification time is equal to k into v by sa whole square. Clear? Now see, what is the volume for a sphere, right? So just now we have seen these things. So let me apply these things, right? So see, for a sphere, that is V by SA is R by 3. V by SA is R by 3, right? So I can write as V by SA is R by 3. This is my total solidification time. This is my total solidification for time for this. But see, the problem is that volume is same. Volume for all the three cases, cylinder, sphere and cube, this is same. So I can write as this would be my volume, 4 by 3 pi r cube. So let me write these things in terms of volume. So r cube will be 3v by 4 pi, 3b by 4 pi. So again, this would be r is equal to 3v by 4 pi to the power of 1 by, because volume is same, so I have to write in terms of a volume, right? Now see, this is a case, now if we take about if we talk about like this is the, we are talking about sphere, right? We are talking about sphere, so let me write it here, sphere. Like, we have talked about volume. Now let us see about the surface area. What is the surface area? Surface area is a 4 pi r square, right? Now see, what is r, sir? In this case, we have seen r is equal to 3b by 4 pi whole to the power 1 by 3. So we can replace these things as 4 pi 3v by 4 pi to the power of 1 by, ठीक है? तो ये तो हमें समझ में आ गया. Now see, these things we have understood. Surface area is this and volume is this, right? And we have converted this to with r. So this is the case of a sphere. This is for a sphere. Now let us solve. Okay, so page is over. Let me take some pages. Just a minute. So so what we have seen for a sphere, this is the scenario. Now let us see for the next is what, for a cube, right? For a cube, let us see for a cube what is the scenario for a cube. So for a cube, what are the scenarios, sir? What is the scenario for a cube? See here, for a cube, the volume would be a cube, right? The volume would be a cube. So can I say that surface area will be what? Surface area will be your pi r square. So this is like, we can say that let me say that a cube is there, so this is 6a square, 6a square is there. So let me convert this in terms of a is what? A will be your v to the power 1 by 3, right? V to the power 1 by 3, so 6 v to the power 2 by 3, right? This is my surface area. I'm just converting these things in terms of the volume, because volume is same, right? We know only one thing, that volume is same throughout the things, right? So now if we talk about the next thing that we should talk about, what is the thing that we should talk about is the cylinder, right? Next is your cylinder. So let me write for a cylinder. So this is for a cylinder. So what is happening for a cylinder? This is the thing that is happening for a cylinder. What is the volume? Volume would be pi r square h, right? See, in the first scenario, what we have seen that h is equal to d, So from here again, I will be getting as r is equal to 1 by 2 pi. So let me say that v would be there, right? V by this to the power of 1 by 3. So from here again you are getting the r. So from here you can find the surface area. Surface area would be like surface area, you can say that this is your these things. See, surface area would be 2 pi rh plus 2 pi r square. So just replace the r with these terms here. So 2 pi r would be v by 2 pi to the power 1 by 3 into h. So h is actually same thing is there. So let's just replace these things. Just replace these things. So after replacing, you will be getting these things, right? You will be getting these things. So after that you just take the ratios and then you will be getting the answer. So this is the one way, this is the one way to solve the problem. And the next way that we can see here, see if there you will see there is observation from here, the total solidification time is actually proportional to 1 by of sa, right? So if so in this method, from this method we can also solve. And the next alternative method that we have, the total solidification time is actually is equal to K into volume by SA whole square. This thing we know. Now if we can use this data that is proportional to only SA, this is proportional to only SA, so from here only we can solve the thing. So just find the SA for the cube, for the sphere, and for the cylinder, and then just you compare them and then you will get it, right? Then you will get it. And the result is that cube casting will solidify fast, and sphere casting and sphere shape will take more time, right? Sphere casting, sphere shape will take more time. Let me write it here. Sphere shape will take more time, take more time than the cylinder. So this is the main data, this is the main data that is have. Do the calculations at your home and you will find these things. Okay, so what is the main conclusion? What is the main conclusion is this is the main conclusion, this is the main conclusion. If you remember this thing, then questions are directly asked in gate from this data only. Questions are directly asked in gate from this data only. So till now if you have any doubt, feel free to ask with me. If you have any doubt, you can ask with me. I'm waiting for your questions and queries. Okay. So what I can write from here is that total solidification time for a cube should be greater than total solidification time for a cylinder should be greater than total solidification time for a sphere. So this was the thing for the today's session. If you have any doubt, feel free to ask with me. I'm always here to help you. If you have any doubt, then ask with me. This is the thing that we have seen. Total solidification time for a cube is greater than total solidification time for a cylinder, and this is greater than total solidification time for a sphere. So if you are planning for a plus subscription, or anybody in your network, in your friend circle, in your peer circle is planning for a plus subscription, refer them my code SIRVK, SIRVK, and you will be getting a 10% off for this, as well as I'll help you throughout the preparations. So this is what is from my side, and you can follow me at Unacademy, that v.kaser, v.kaser. You can follow me there. You can follow me at this unacademy.com at the rate of v.ksir. I'm posting a lot of lectures there. Currently, I'm teaching the strength of material there. Anytime when I will post a new lecture, you will be getting notified there. So, thank you. Fulbright, uh, I tried my level best to simplify the concept. चीजें क्या होती है ना, मैन्युफैक्चरिंग एक हैवोक है. मैन्युफैक्चरिंग जो है दिखता बहुत भयानक है, लेकिन उसको सिंप्लीफाई करना पड़ता है ना. So I tried my level best to simplify the concept to you for metal cutting. So I'm really glad and very happy that you are actually getting benefited with the metal cutting lecture. I'm very happy. Thank you so much for your feedback. Assis, this, after this, uh, Assis, see, you have told that where is the assistant? How many more topic will be left after completion of casting? See, after completion of casting, like these things in casting, if you talk, riser design is there, and little bit more topics are there. And after that, we will going for a special type of castings like investment casting, that some other castings are also there. Precision castings are there. Slush casting, these things are there. Okay. तो कास्टिंग में अभी हमें आई थिंक लाइक more two classes would be there, more two classes would. Can you give me a brief about your crash course? Yes, in this crash course what I will be doing, I'll be focusing uh, in completing the thing in a very limited time, as well as I will do a crash course for GATE and ESE. That would be crash course for GATE and ESE, in which uh, pattern would be same. I will give you the concept, clear your concept. I will be getting into more details with their, right, डिटेलिंग में जाऊंगा मैं. वहां पे कॉन्सेप्ट्स पे आपका ध्यान दूंगा, कॉन्सेप्ट्स पे आपका ध्यान दूंगा. और एप्लीकेशन के लिए मैं आपको प्रीवियस ईयर पेपर्स का क्वेश्चंस ला करके सॉल्व करवाऊंगा. सो ये मेरे क्रैश कोर्स में है. एंड इफ यू आर डूइंग माय कोर्स, आपको और कहीं जाने की जरूरत नहीं है, दैट्स फॉर श्योर. आपका सारा डाउट्स यहाँ क्लियर हो जाएगा. थैंक यू सो मच शुभम राज, थैंक यू सो मच. Mukta, that is research and development. So firstly you have to go for a masters, or if you have a good marks, then I will say that go for ISC. Go for ISC Bangalore. ISC Bangalore has a lot of great place to work for research and development, right? तो research and development में अगर काम करना है, आपको सेक्टर में काम करना है, तो for that you just give the gate very good marks, get into very good IITs, or even in any even in any ISCs, like even ISC also. When you will get the chance, then आप एमटेक करें वहां से, या फिर आप डुअल डिग्री ले ले, डायरेक्ट पीएचडी ही करें वहां से. और एक बार आप जब कर लेते हैं वो रिसर्च प्लान जब आपका आ जाता है, then apply for any labs like CSIR labs are there, any lab is there, and from there you will get a job of a scientist. From here you will get a job of a scientist. Okay. मशीन डिजाइन का कुछ यूट्यूब पे फ्री आ सकता है क्या आपकी तरफ से सर? फुल ब्रैट, अभी तो मैं मैन्युफैक्चरिंग कर रहा हूँ. आप मुझे मेरे अन अकेडमी ऐप पर मुझे आप फॉलो कर ले, वहाँ पे मैं स्ट्रेंथ और मेटल तो पढ़ा ही रहा हूँ. मैं अन अकेडमी मैं डिज़ाइन में देखता हूँ. गिव मी सम टाइम, लाइक after 1 month I will be publishing a lot of things, not of the machine design, for example for heat transfer, or for some important topics, right? For important topics, for example heat transfer में radiation में बहुत problem हो, maybe for that I will go for that. For example डिजाइन में आपका फ्लक्चुएटिंग लोड्स में प्रॉब्लम होता है ना? तो उन सब चीजों को मैं डेफिनेटली करूंगा. सोडरबर्ग, जर्बर्स लाइन एंड दीज थिंग्स, आई विल डेफिनेटली ट्राई माय बेस्ट to give the things. Ashish Yadav sir, please try to complete the full management. हाँ मैं कर रहा हूँ, मैं कोशिश कर रहा हूँ, आई एम ट्राइंग माई लेवल बेस्ट। एनीथिंग एल्स? एनीथिंग एल्स? हाँ, इसरो डीआरडीओ तो है ही। इसरो डीआरडीओ में प्रॉब्लम्स क्या होता है, देखिए, इसरो डीआरडीओ में आपको तो एग्जाम देना ही है, इसरो और डीआरडीओ तो निकलता ही है, बार्क भी होता है ना, बार्क भी होता है। अगर आपका अच्छा मार्क्स आ जाएगा तो यू विल बी गेटिंग एट एनपीसीआईएल, यू विल बी गेटिंग अ पोस्ट ऑफ साइंटिफिक ऑफिसर, राइट, साइंटिफिक ऑफिसर। एंड साइंटिफिक ऑफिसर भी तो आपका रिसर्च एंड डेवलपमेंट में होता है ना। तो गेट आप दें, अगर गेट से आप अच्छे जगह पे घुस जाते हैं ना, तो वो बहुत आपके लिए बेनिफिशियल होगा। ठीक है, गेट तो बिल्कुल दें आप। हुँ, तो गेट से आपका बहुत कुछ मिलता है। और इसरो का आपका अपना पर्सनल एग्ज़ामिनेशन भी होता है, सो फ्रॉम देयर यू कैन आल्सो गो एंड गो फॉर द आर-एन-डी सेक्शंस, साइंटिस्ट की पोस्ट होती है चीज़ें। हुँ, येस डेफिनिटली आई विल ट्राई माय लेवल बेस्ट टू कंप्लीट द मैन्युफैक्चरिंग। ओके, सो आई थिंक you don't have any doubt, right? Don't have any doubt? And if you don't have any doubt, then I am just ending the session, okay? And before ending the session, remember my code